Good afternoon. Welcome to this quick seminar. My name is John Skika. I'm from the SAP Big Data team. I'm going to talk to you today about harnessing big data in real time. We're all here because information processing is at a critical inflection point. It's gone from what traditional systems can handle to a point where you need to change how and what you're doing. And one of those changes is integrating across a data fabric. So SAP HANA gives you instant results. Hadoop is a platform that can be used to hold mass amounts of data and also pre-process mass amounts of data. It gives you a data lake where you can explore, where you can mine, where you can find the data of value, take that data of value and either move it into systems such as HANA or link to it from systems such as HANA. And that's what I'm going to talk to you about today. How we can make this work, how we can make this interaction, and how you can combine the instant results you get from HANA with the power that you get from Hadoop to get that real-time predictive analytics that'll give you what you need. When it comes to Hadoop, SAP has an open strategy. SAP will take its big data stack, the SAP HANA platform at its core, to help you acquire, accelerate, analyze, visualize, and act on data, along with all the component parts that SAP has, from data services and data connectors to move the data back and forth, to smart data access that I'll talk about later to allow you to virtualize data from other data sources, along with geospatial, the predictive, the text analytics engines that are in HANA. And we work with Hadoop. We work with Hortonworks. We will work with Cloudera. We work with MapR. That said, Hortonworks is at the top of the list, not just because I'm here at a Hadoop summit that Hortonworks is the prime host for, but also because SAP has a special relationship with Hortonworks. SAP has a reseller agreement with Hortonworks. That basically means it's a single source for customers in terms of bill of material and purchase, but also a single source of support. The support is sold through SAP, and SAP will do level 1, 2, and 3 support. Anything beyond that will be passed on to Hortonworks. But as far as the customer is concerned, there's one touch point for sales, there's one touch point for support. We also are working with Hortonworks. We're just finishing up certifying Hortonworks 2.1 with SAP HANA. And in addition to that certification, we're currently working on Yarn integration, as well as integrating Umbari into the SAP Big Data structure and platform. And this is what SAP sees as that big data architecture. The applications that SAP is known for across the top, we have a bunch of ERP applications. We have big data applications we've created. SAP Analytics, our BI suite, along with Lumira, that can either reach through Hadoop, reach Hadoop through HANA, or can actually be mined by connecting through Hive, going directly into Hadoop itself to give you the analytics and visualization you need that way. But when we take a look at this structure, you can see that it isn't just one data platform. HANA is the core, HANA is the orchestrator. But beyond HANA being the orchestrator, we have a bunch of diverse data systems that we realize exist. Data exists in various data structures and systems because they're optimized for that data. And I want to lever them to serve the data as best possible. So I have a bunch of data sources that can connect through to HANA or through to Hadoop itself directly. We do have SAP Event Stream Processing for real-time management of data and SAP Data Services to move that data that both have connectors down into Hadoop. So I have the capability of working with those directly. We have SAP Landscape Transformation that will actually allow me to move data and structure that. I can do the ETL, but I can also do Smart Data Access. And I'm going to talk about Smart Data Access in a bit more detail later on. But basically what I can do is create a virtual table in HANA. And as far as the end user is concerned, as far as the application is concerned, it is a table in HANA. So when they hit that table, they assume they're hitting a table in HANA. HANA knows that there is no data associated with it directly in its database. It actually will drive that work down to the target system and return the results. and it's smart enough to actually do some interpretation for you. So you have told it what to do in a particular language. HANA will actually take and translate what you've asked to be done into the way the target system understands it. And it's also smart enough to know whether the target system can deliver that result or not. If you've asked the target system to do something it's not capable of, HANA will actually take the data out of the target system into itself, do what you asked it to do, and get the result set itself. So what we're actually looking at here is what Gartner refers to as a logical data warehouse, what Forrester refers to as a virtualized data warehouse. We're looking at a unified data fabric. We're not saying data sits in one system or sits in another system. What we're saying is you will have a number of systems throughout your enterprise for a number of reasons, and what you really need to do is bring them together seamlessly. And what I described isn't too much different than the modern data architecture that Hortonworks talks about in terms of how all these pieces come together and work together. And we have some use cases. Probably one of the best use cases that SAP has, along with Hadoop and R, has to do with genomics. So data is something that is used and worked on, but we have hit a stage where we have the capability to hold and process more data than we have the capability ourselves to do. We need to rely on the machines to do it. And when you take a look at the amount of data per genome and the amount of all the known variants and the 15 petabyte database that has to be worked on in here, all of this is a mass amount of data that needs to be churned, worked with, and viewed seamlessly. And one of the most critical things here is time. I can do this, and it was possible to do exactly what I'm going to describe, and it took a number of days. And the problem is, when I'm dealing with cancer treatments, when I'm dealing with optimizing the way that I'm going to aggressively go after a cancer, I don't want to wait a number of days. First off, in terms of results, and second off, in terms of just the comfort level of a patient. So basically, what we did was we worked with a company called MK out of Japan, and we pre-process a great deal of data. So there is pre-processing going on. There's the alignment of DNA sequences from cancer to normal. And then there's the data analysis. And that variant calling from pre-process sequencing is what is done in HANA in the real time. And then we get a list of actionable mutated genes, and we can actually create, based on a predictive model, the treatment path and the prognosis that should best be followed. So we actually have a suggested path. And the speed of processing is really what drove this. So Hadoop is used for the pre-processing. And the original processing took 2 or 3 days, and it contained many manual pieces to it. It's been optimized down to 2 or 3 hours with the high-spec machine, and then throwing HANA in to do the advanced analytics actually accelerated things down to 20 to 40 minutes using HANA and Hadoop together. So we got rid of all the manual tasks, and we rapidly speed up the analysis and the response time. So we've gone from 2 or 3 days to 20 to 30 minutes, which is substantially impactful when you're talking about one peace of mind for someone who's been faced with the challenge of cancer, and 2, in terms of prognosis and how quickly you can deal with it. So you're looking at, using HANA, Hadoop, and R, you're looking at something that is 400,000 times faster than traditional systems. Something that's 216 times faster that went from 2 to 3 days to 20 minutes. And that accelerated benefit really is the value here. So we've got accelerated predictive and correlation analysis done in memory in HANA. We've reduced the time to detect the variant DNA, and we've optimized the treatment plans that can then be implemented. And that really is the most significant factor, is the fact that we're able to do this in a timely manner. And it really is a compelling story of how you can use SAP HANA along with Hadoop and R to achieve something that really is life-changing for a number of people. And when I take a look at this, there are a number of ways that I can use this architecture. machine data. So we're looking at sensor data that is coming in. And when I take a look at a prototypical machine data use case, I've got all the ERP data that I have, because that's one of the biggest things that we have to realize, is that we're not just dealing with data subsets. We're trying to get a holistic picture. We're trying to combine data from multiple data sources to get a holistic picture. So I've got the traditional ERP data, the enterprise data. I have other data that's coming in, such as machine sensor data, the machine logs. I've got mobile data coming in. And I have real-time replication and ESP streaming processing driving data across into HANA and into Hadoop. And I have analytics and applications that are sitting on top of that people access. And I have the large, low-cost storage platform that is Hadoop. And I have the historical data in there. I have the offline batch processing. This is where I can do my exploration, my mining. I can build my algorithms. I can see what data is of value. And I can either leave it there or move it up when I realize that it's useful. And I have the SAP HANA in-memory architecture that is more than just a columnar database. I mean, it's a built-in application server. It has transactional and analytic capabilities. It's got graph, spatial, natural language libraries and engines built into it. So I can get real-time operational analysis. I can deal with billions of events per day. I can correlate millions of events. I can do things such as energy optimization. I can take a look at predictive maintenance. I can take a look at inventory management. I can even do route management. And if you come by the booth, we actually have a quick demo that shows that. SAP has built and has worked on for the last couple of years a smart vending machine. So I have a vending machine that is wired and connected. And I actually have the history of that machine. I can see the sales. I can actually pick up the demographics of people using it. So I have a great deal of point of sales data that I have. I also have the inventory and supply chain, and I can correlate this with weather. But the machines are also telling me stock levels, and I can predict, based on buying patterns, when a machine will run out and when a machine will actually be out of sales, and I don't want out of product. And I actually have the capability of looking at all the machines together and those machines working. So a driver leaves in the morning and they have a planned route. They know that they have to fill up certain machines with certain amounts, but something has changed. People have gone and purchased something. The machines will actually sense and talk amongst themselves. ESP will trigger HANA, and HANA will do some analytics, and I can actually reroute the driver throughout the day. They may be going in the morning as they envisioned it, A, B, C, D, and then based on events that happen during the day, they'll go A, B, E, D, C. And all of this will transparently happen, be pushed out to the driver. And I can actually use Hadoop because when I'm building these predictive models, when I'm looking at this, the more data I have, the more accurate the model is. Therefore, I need something along these lines to actually drive this and push it out. It may not be machine data. It may be people. It may be customer behavior that I'm looking at. When I'm taking a look at point of sales, when I'm taking a look at customer behavior and segmentation, when I'm taking a look at campaigns and what I can drive in terms of pushing this out. So I have the capability of actually taking a look at how people behave, what people do, what the weather is, and actually take a look and predict based on that historic data and the social data that's coming in and the clickstream data that I'm seeing from the stores, and actually be able to build predictive models that will help me drive inventory and place what I place in the store, devise offers, and how I'm going to do that. And all of this works very well, and it does give me that real-time analytic capability. But I also have to think about how I'm hooking all this together. And I can talk about a number of products. So I've got HANA in memory for that optimized real-time insight. I have Hadoop, my massively parallel processing HDFS, where I have my data lake that I can explore, I can build the models. I can cost-effectively hold a year's worth of data. SAP and Hadoop have built a demo. And in that demo, we have 18 months, some 5 billion records sitting in HANA, and we have 48 months, some 15 billion records sitting in Hadoop. And using Lumera, we actually mine that data. And it's a seamless, as far as the end user is concerned, as far as the person working the dashboards and getting the result sets back, you have no idea you've moved from one database to another. You have no idea you're dragging data from one or from the other. It really is a seamless piece. So I have data sitting in Hadoop, I have sitting data in HANA, and as I mentioned, when I take a look at the data of value, I've used my data lake, I figured out what the data is of value. I may use ETL, I may move data from Hadoop into HANA because it's time critical and I need that immediate instant response. I may leave it in Hadoop, and I may use something like Smart Data Access. And Smart Data Access basically allows me to create a table in HANA. And as far as the end user is concerned, as far as the application is concerned, they've hit a table in HANA. But that table actually will drive the work into or down into Hadoop. So a query or an application says, I need to join table A to table B. Table A is data in HANA. Table B is actually a pointer to Hadoop. HANA will then cause the work to be done in Hadoop, and that result set to be returned and then unified with the first table. And that is done seamlessly as far as the end user is concerned. And as I mentioned, it actually is done in a way that translates what I've asked HANA to do in SQL into what will be done in Hadoop and optimized. And there actually is a recommendation engine that will come back and say, based on what you've been doing over the last 3 months, you may want to consider moving some of the data out of Hadoop into HANA because you use it regularly. And you want that instant response on it. You don't want to wait for HANA to do the response. Or you may want to build aggregates in HANA to actually speed that up a little bit. I also can, through both IQ and HANA, I can actually write a user-defined function in Java that will kick off a MapReduce job in Hadoop. So basically, in HANA, I'm writing the application. The application calls a jar that will actually kick off that MapReduce job down in Hadoop for me and return the result set. So I can do a lot of things in that one orchestration place without actually having to move into the other database and do work. And that really is the biggest advantage of all of this. And it really is what gives me the power to get instant results with a very large data lake and get the best of both worlds. So I talked about moving it. We can use ETL, and we have landscape transformation. We have SAP data services that are optimized to move data back and forth. Data services itself is a GUI-driven piece. It has been worked and cooperation with the Hadoop world. It is built for high performance and reading and loading into Hadoop. It has got an extended optimizer for Hive, QL, and Pig. And as I mentioned, it can do that MapReduce pushdown. It can actually do text processing or entity extraction for me as well on the data moving back and forth. And it's very simple to use. I mean, based on the target system, and it doesn't have to be Hadoop. It could be something like another database, but in our case, Hadoop. Based on the target, SAP Data Services translates the query into Hive QL or into a Pig script for HDFS. And then the Hive or Pig converts the query into MapReduce jobs for work in Hadoop itself. The results files are compiled and brought back. SAP Data Services basically takes those threads, and the data quality is one of the biggest pieces of this. There's some data quality involved in this as well. And then I basically load the results back up into HANA, the database. So I have this, and it is seamless, and it is very quickly and easily done. But it is something that is done quite well. And one of the things that Smart Data Access allows you to do is I don't have to worry about different modeling environments. I don't have to worry about selecting different databases. I merely make a call from one place. I have my modeling and development environment in HANA, and I write one SQL script, and that one SQL script will drive down into the databases through the virtual tables, whether it's Hadoop through Hive or whether it's another database itself, such as Oracle or Teradata. So I really have that unified capability. One of the problems with ETL is there's a cost to moving data. Ideally, in this data fabric, I want data to stay where it is because I've placed it where it optimally belongs. I don't want to move data back. I mean, moving data back and forth, the cost isn't only people and the effort in moving it and the time to move it and the bandwidth to move it. It's also security and other things. I have one copy of the data, and I know who has access to it and how they can access it. And then I decide to take a copy of that data and put it someplace else, and then a copy of that and put it someplace else. And all of a sudden, I've lost control over who has access to what data. If I can leave the data where it is, I have a lot of advantages. And this is the way to do that. I can remotely move across the data. As far as everybody's concerned, it's a local table. It's not. It's a virtualized table. I have the ability to do smart query processing, and I can support localization. And again, we talked about the syntax being moved. So it really is an invisible way to move data across this, or to work with data without moving it across this heterogeneous environment. And using the pieces that are optimized to run it. And it's very simple to do. So I have tables in HANA. I have tables in a remote system. I create a virtual table in HANA. And that localization, as I said, is transparent, other than for the person who's created. And I merely create virtual table at and point to a data source. And it really is very simple to set up. And at that point, anybody accessing this table now is looking at the virtualized table across the unique data store. So I can actually cache this as well. So when the virtual table is created, the catalog is updated to include the local column names. But I also can cache this table so that if there is a change in the target system, so if data changes in Hadoop, that table will be updated automatically. So anytime I hit that table, I'm getting the latest update information. It's very simple. You create the table in Hive. So on SAP HANA, you create a DSN, give it a name Hive 1. You go into HANA Studio, and you basically create a remote source, and you basically put the credentials to get in, and you basically create a virtual table at, and then you select from the table. And when you're done with it, you drop the table. It's very simple. It's very seamless. It's very easy. This gives you the ability to work between multiple data stores. So HANA does have an optimizer when the query comes in. It can parallelize within itself. It also knows where it has to send the information to get it. So it will split the query into different pieces that it actually executes. It may do some in HANA. It may do some in Hadoop. It may do some in a third database. And it will bring all those pieces back together. Almost sounds like I'm talking about MapReduce. We'll bring all those pieces back together, consolidate them into one simple result. As far as the application is concerned, nothing has happened. Everything's come from HANA. It's invisible to all the other pieces. I talked about kicking off a MapReduce job through HANA. So basically, I actually am working in HANA, and I will create a jar file that contains the MapReduce script, so I can calculate a word count in this case. I create a virtual function, word count, return the table from, and I'm mapping through to. So basically, I can, by setting this up properly in HANA, have people access things that they don't necessarily have the skills to access. They're SQL programmers. But they're able to do things in Hadoop because I've enabled it for them. I've created what they need to do, and they're able to do it themselves. So basically, I've enabled their skill set. We talked about ETL, so we've got that faster loading through data services. We've got Falcon and the load transform with the MapReduce and PIG, with the parallel loading of the data that I see as valuable into HANA to actually utilize the spatial or predictive engines that I have up there to get that real-time capability with that ability. And I basically have the ability to take and offload the processing down to that data reservoir that I have, that data lake. We can do interactive data exploration. So I actually can take a look through visualization and reporting. And as I mentioned, I can either go through HANA, or the BI tools in Lumeric can go directly down in through Hive, through Interactive SQL, down into Hadoop, and bring back the information. So I can actually then take a look at ways of agile modeling and getting things to turn around faster. And I can explore the data lake, both in memory and interactively within Hadoop. We've got the real-time streaming capabilities. So we have SLT and ESP and replication server that can all be used to drive data back and forth. And the event stream processing probably is the key to this, because the event stream processing is what data is going to be flowing. But from those online ops, I'll have alerts that will either trigger events or cause actions to happen. And we can build those models in the same way. We actually are doing this a number of places. Kaiser Compressor is doing preventative maintenance. They're going beyond selling compressors. They realize as a manufacturing company that I can sell so many compressors, and when they wear out, I'll sell more compressors. But I can also sell something else. I can now start selling a service. Because all my pumps are monitored, all my compressors are monitored, I'm actually able to sell not just the pump, but I can actually sell a service. I can sell the ability to get preventive maintenance alerts. So rather than waiting for a pump to fail and you having to replace the pump, I can actually tell you, based on the sensor information I'm getting, and not just from you, because I'm going to correlate this with data from all the pumps that I've sold, I'll be able to tell you, hang on, the pump's going to fail. I originally predicted you a lifetime of 150 days. I'm now telling you that it's going to fail in the next 15. So you better start thinking about ordering a replacement and getting it in. So I've given you a value-added service. eBay is actually doing amazing things. Like they've got over 50 petabytes of data that they're dealing with. And they've got a lot of noise. And they're looking for signals and patterns in that noise. And what they're doing is to their sellers. So eBay itself provides a service to a whole bunch of people who sell on eBay. What they're doing to their sellers is they're actually able to go in and predict and talk about what demand is, where prices should be set, what is going to sell or what has been selling. So again, offering a value-added service to the people that are my customers and giving them some insights that they may not necessarily individually have into how and what they should do to drive their business. And again, the POC of this actually had HANA doing the real time and Hadoop being the massive data lake for the mass amounts of data. And there is a lot of work that goes on here. We have a data science team that actually will sit down with people and help them figure out how to do it. We have Lumera that actually will sit down and help you visualize. Now, I'm looking at a couple slides that I didn't see, but that's fine. I have them in the booth if you want to come by. There were 4 slides that talked about the way I saw the value. So using HANA to drive 4 particular types of value in conjunction with Hadoop. Does anybody have any questions? I've got 10 minutes left of my speech. Yes, sir.
Yes, I'd like to know about published data catalog, so we can look at sources that are available through the Smart Data Access tool that we want.
Okay.
Any types of role-based authentication or access control so that we can give somebody permissions from the catalog. So when somebody requests it, we can say, here's your permission to go look at that. And then third, security type tools, for example, on-the-fly data masking or de-identification of the data so that that data owner could take and either mask it or de-identify it if they had to on the fly.
Okay. So let me try to remember the questions in order. Yes. So again, you're sitting and you are looking at any data type. The catalog, once you create the virtual table, that catalog in HANA is automatically updated. Okay, so it's nothing. Once you create the virtual mapping, HANA will maintain that catalog for you. It can't, because it merely is a tool to connect them, but SAP does have tools to actually help you map where data is. They actually come from the Sybase world. And so you are able to actually, before you do any of this, sit down and they will basically map out where data is and help you figure out how you're going to actually combine it, whether you're going to move it or whether you're going to map it to. So no, this particular, HANA doesn't have the capability, but SAP does have tools that help you do that. And the security, that's why I brought this slide up. So you actually can set credentials, and it's either for, normally what you're doing is you're setting credentials for a group, okay, to access. And you're getting in through this. So as far as the user is concerned, I've already configured that access for them, and they will go through. It does. It interacts with LDAP, yes. So it's LDAP. So when I'm taking a look at this user defined, it's an LDAP. It can use LDAP as one of the lightweight data access. So that would actually be parts of the individual products. When you're talking about moving the data back and forth, that would actually be part of data services or the landscape transformation that would actually give you the capability to do that. So again, when I talk about all of this, I'm talking about a fabric. I'm talking about a number of products that are brought to bear to make this. So SAP has products such as landscape transformation and data services. However, that said, I know that there are a number of customers that I've been engaged with where they have a particular tool they want to use, and we can make them work with the SAP landscape. Yeah, we can make it work. I can't give you, on specific ones, I can't tell you, but I can tell you that we are fairly agnostic, and it isn't that hard to make them work. Anything else? I thank you all for your time.